Hi, everybody. We're going to go ahead and get started here. Thank you for coming to our panel on build systems. We have four great panelists here. My name is Zach. I work at Slack. I'm going to be your host today. I guess we'll go ahead and just get started with some quick intros if we just want to go down the line, starting with Erik. Introduce yourself, where you're at, what your experience is, why should people listen to you?
Hi, I'm Erik. I work at Slack with Zach. I am nominally an iOS developer here, but I've spent about a decade on various platform infra teams. Target is where I started. I helped migrate Target iOS to Bazel, came to Slack, did the same for iOS at Slack, migrating to Bazel, and I spent about a year toying with Android Bazel, which I'll talk about today.
Cool. Hi, everyone. I'm Jonathan. I work at Block on iOS developer experience. But previously, I worked as an Android product engineer at Slack and then on mobile developer experience broadly at Slack. So I've touched a lot of Gradle, a lot of Bazel, and yeah, just a lot of time with build systems in general.
Okay. Hi, my name is Nari Shin, and I currently work at a company called Hinge. So I'm an Android engineer, and I actually don't have much experience in Gradle, but I worked on some of the modularization, which is kind of like adjacent to that work. So yeah, that's how I'm here.
Hey, I'm Inaki Villar. I'm solutions engineer for the Velocity. So I'm working with different companies with the Velocity features that provide like troubleshooting, observability, and acceleration. Before that, I was a build engineer, member of platform core teams for different companies on the under roles. So yeah, that's it.
Cool. Thank you all. So we're going to start with just some questions that I've been sourcing from community beforehand up here, and then we'll pretty quickly after that open up the floor for audience questions. To start things off on a possibly spicy note, and I want to kind of get a sense from each of you on this. What's your like high level feel of like the Android build ecosystem right now? Do you think it's good? Do you think that it's falling behind other build systems? Yeah, how are you feeling about it?
Well, I will start. So I think that nowadays, so the Android ecosystem in terms of the build system, Gradle, it's very mature. The Android Gradle plugin, the Kotlin Gradle plugin are very mature or main build stack components. But it's true that today at 2025, we have different challenges that we didn't have like maybe 4 or 5 years ago. We have projects with 1,000 models. We have thousands of network requests for caching, configuration times, and we have new challenge. That's what I would say here.
So at Hinge, I feel like we have a pretty modern build system, which we utilize conventional plugins, and we also use a lot of like dev velocity features like configure cache. So I feel like compared to my previous company, which was I used to work at Twitter, and then it's like a lot of like engineers and the code base is much bigger. So the build time took really long. So like when you wake up, like you start the build first because it usually takes 40 to 50 minutes, and then you make coffee, and then like 1 hour after you come back, and then you start working that day. But yeah, compared to that experience, I feel like Hinge's build system is much because of all those like work and optimization, or maybe because of the code base. I feel pretty comfortable now, and I feel like all the like development improvements and features, I feel like it's getting better.
Just to give a little iOS flair to things, having worked on Android and now iOS more, I think Android has a really good thing going with Gradle. The fact that the tooling is open source, that the Android Gradle plugin is open source, you can kind of look at what's happening. On the Xcode side of things, you're just spending a lot more time kind of reverse engineering what's going on with Apple. Yeah.
things are really good. If you worked in iOS, you know that what you have out of the box with Gradle today is a glass of ice water in hell. You can write code to get your build system. Xcode build is essentially a WYSIWYG. If you've ever tried it, it's absolutely terrible. That said, like, there's a lot of choice, and that can cut both ways. There's Gradle is, of course, the default. That other companies and teams try other ones might indicate there's other areas of emphasis that they want to go for, be it caching or speed. But overall, it seems like it's in an overall great place, and sometimes choice and different options are a good thing to have.
Yeah, and I'll also say, I think we're in a good place. I think it could also be a lot better. I think if you go to the other side of the conference hall and learn about Flutter's hot reloading, you know, there are amazing developer workflows that mobile developers just don't have access to right now.
So most of you, all of you maybe at some point or another have worked on something like a developer experience team or infrastructure team that is responsible for this in your company. What point in a company's or a team's size do you think it makes sense to have like dedicated resources on a team like that? You know, is there like a good heuristic or inflection point where you think it makes sense to have someone who is specifically focused on maintaining your build? Or do you think that's something that just kind of arises organically at different points for companies?
It's going to be organic, I think. If you're at 50, you're for sure probably, I assume, need that. I don't know if like 20 is a break point, but what you find out is eventually you have, if you informally take care of it, you're going to have something struggle. And the second you notice that, I think that's when it's time to have somebody dedicated to it, because that person's probably going to be trying to do something totally unrelated. They're going to try to be building a feature, but they spend a week on your build system. The person who wants that feature done is going to kind of say, hey, wait a minute, we want, you know, a better way to solve this.
Yeah, I'd say in my experience, you often have people who kind of gravitate towards working on the build system, and people who just want to build their feature and get in, get out, and want to touch, you know, Groovy as little as possible. And then I think as your team gets larger, it just makes sense to kind of actually codify those divisions and say you can work on the build for real. But I think, yeah, it probably only makes sense once you have a pretty large team and people are complaining about builds.
Yeah, pretty much the similar idea, but yeah, as soon as your team kind of reaches at the point where like everyone is kind of complaining about the build time, and when the pain is becoming like more painful, then I guess that's the time that the companies kind of starts investing in it. Also, like, you know, like having that kind of build engineer is also like a lot of cost. So if companies backing the team to do it, I think, yeah, it's good to have.
Yep, nothing to add there. So at the moment that you have a Gradle folk in the team, that's the moment that you need a developer productivity experience team, right? So,
yeah. What are your team's core metrics, and how do you decide on them, and how do you track them down? And also, when they change, how do you decide if that change is acceptable or normal? For example, you know, your build times maybe go up, but also your code base is getting bigger. Some of that is to be expected. Yeah.
As you know, time to merge, which is a really weird way of saying time for CI to turn green, is our core metric, or one of our core metrics. Overall build times are, of course, one of them. And how do we decide on them? Well, gosh, they're easy to measure is unfortunately a good answer there, in addition to being a decent proxy for how efficient your builds are. What I don't love about, you know, some of our metrics, like build times are a tough one, because what are you actually measuring? Nominally, we measure somebody starts a build and the build completes, and you kind of like average that or median that, and that's a really messy number because you don't have a control in the experiment. about is that an incremental build, is that a full build? It all just kind of gets put into one giant messy pool and averaged out. So I guess those are the two big ones, and I won't take too much time.
Yeah, echoing that, I think it's really helpful to have kind of a division between your sort of like live data of what are developers actually experiencing in the field. And I think using something like Develocity is great for that. And then I think it's also important to have benchmarks that are going to be much more stable. And there are tools like the Gradle Profiler that let you kind of set up scenarios where you can say, okay, I'm modifying a file in this module, run my benchmark, run it a bunch of times so I have confidence that it's not noisy. And so yeah, I think those are kind of the two metrics we look at.
So if I just focus on like the build time as like a core metrics, and then from my perspective, which is more like a modularization perspective, there are multiple ways that you can kind of set up on the core metrics and try to optimize as much as you can. So there are some like concepts like between centrality, which kind of defines how like which module becoming a bottleneck for your build. So those kind of like improving on that kind of metric, or like just simple like the graph height, flattening the graph as build graph as much as possible. Those all helps when you parallelize your build system. So so in that sense, I would also like think about like a modularization as to improve your build system.
Well, so from the velocity perspective, so we have different customers in different metrics, and well, time to merge, build times, overall, that makes sense depending on the requirements that they have. So, well, I don't have a concrete answer about this question, given that we are providing the tool to monitoring the build times.
I really like the answer about modularization because we also use that same betweenness centrality algorithm at Slack. Talk a little bit more about sort of, say that you're giving advice to a team or a company that is trying to get into a modularization flow. So maybe they have, a handful of modules and they want to try to broaden out. What are the the green lights they should be looking for and lean into, and what are the things that they should be mindful of, costs that they may not foresee, and also what are the structures that you have seen work well in a large code base to make it both better for your build and also easily accessible and grokkable to feature engineers just trying to work in that code base?
So I feel like if you look at your code base and the module structure, they also kind of tells you like how your team is structured. So like for example, like in our current company, we have about like 500 modules, and we have about like 20 plus active contributors. And then the strategy that we took is based. Oh, and then like we also do. Oh, sorry. If you don't know about Hinge, it's like it's a dating app. So we have like more like a user-facing features. So most of our engineers work on the feature development. So the strategy that we took in terms of modularization is we introduced like 5 different levels or layers. So we start with the app, and then we have feature modules. And then under that, there's a subsystem module and foundation and core. So, and each layer has like a different responsibility and the scope. And then, the dependency can, there's like a certain like rules that we define as a team to allow like certain dependencies. So I guess, that was our strategy to make the our modules structure to work with our team. Did I answer your question? Or
do you use any? And this is for the whole panel as well. Is there any set of either Gradle plugins or standalone static analysis tools that you have found really help with keeping things organized. Whether it's something that can run on CI or something that makes it easier for developers to add new projects on the fly.
Sorry, can I add one more thing, kind of related to the previous question? So we have this like different layers of module structures, and then we also have we are using the convention plugins. So each plugins that we defined are kind of mapping into each layer of modules. So when you are creating new module, it's very easy to grab all the dependencies for specific module. So that's been really helpful for us.
Yep. So in terms of Gradle, I really like one plugin that's called Graph Assert. This plugin allows you to measure the height, as she was saying about the project dependency graph, and enforce some rules as well in your project dependency graph. So for instance, the feature models cannot depend on itself. But additionally, from the Gradle perspective, I will invite you to explore the API as well. There is like the get components API from Gradle that allows you to retrieve the project dependency graph. So, and at the end of the day, Gradle is a dependency cyclic graph. So you can apply some graph algorithms like between centrality, and you can start seeing a problem of the project dependency graph from a more theoretical approach. Yeah.
One thing or a sibling team has worked on a lot at Block is having a command line interface for generating new modules. I think that's a really helpful tool to kind of enforce norms around the code base, and it just means that it's not a huge amount of work to copy and paste things to create a new module, and it also gives you a nice place to say, hey, do you need this feature? Then we're going to enable it. If not, we can keep your build as simple as possible. Yeah.
It's this great Gradle plugin called Foundry, which we use. Joking aside, opinionated conventions are number one, especially as your team gets big. You need to have repeatable and strongly enforced patterns of what a module is, what it looks like when it's named, where its sources live, how its tests are laid out. And it's the only way I think you can kind of scale and have your team work with each other.
All right, I want to dive into one more subject here, and then we'll open this up to the audience. Specifically looking over at the Bazel crew here. I'm sure there's a lot of people in the audience that are often wondering how green the grass is on the other side. From both of you, especially given that you have gone in sort of opposite directions of this. Erik, you were iOS primarily, and then you've been doing a lot of Bazel on Android the past year. Schear was an Android person whenever I joined Slack, and now we've lost him to iOS. Talk a little bit about your experiences with Bazel in general, but also how viable have you felt that it's been on Android? Are there things that you wish that, things that you like in Bazel that you wish existed in Gradle, things that exist in Gradle that you wish you had in Bazel? I don't know, unpack that. I think a lot of folks know about it, but don't have the same depth of experience that y'all have had with both sides of the fence here.
Yeah, it's very powerful tool, but it has a bit of a progressive disclosure emphasis. Disclosure, not so much progressive on the difficulty. It's a very positive experience in Apple world. And again, I'm gonna go back to my earlier comment that, compared to Xcode build, everything is a glass of ice, water, and hell. And so what you find out is a lot of people got excited about it. A lot of people built some really nice tools about it. So now today, if you go into it and you're like, I want to try this Bazel thing for Apple, there's a lot of really good examples, a really great community. It's like rich. There's like examples. You can dive into it. On the Android side, the lift isn't quite as high. There's some exciting things you can do with it, but the community flywheel isn't there. And so what you find out is the hard part of Bazel will creep up and bite you a bit more than on the Apple side. There's a bit more rawness, a bit more incomplete features, things that you can do, you can overcome, but you need to be very motivated and have a real good reason to do it. But even then, you be prepared to, Bazel is a full-time job for at least one person at a company, and it's not something you take on lightly.
Yeah, definitely agree with that. Also, we should just say Bazel is Google's open source build system. A lot of other build systems have been kind of built on the same general model, Buck at Facebook. And I'll just say that I think it's really important when you start to think about using an alternative build system, if you're the kind of person who gets excited about a build system migration, is just to really think about how much you're signing up for. Because it's not just sort of the command line build and you send it off to the App Store or something. It really integrates deeply with IDE tooling. So how do you power, indexing and code completion in the IDE? That has been a big problem on the iOS world for Bazel for a long time. And I know that there's a JetBrains plugin for Bazel for JetBrains IDEs, but it's still, I think, not the best experience ever. So you're sometimes trading kind of developer experience in one domain for speed in another.
When you're working on a Bazel adoption, what goes into evaluating, for lack of a better word, like, is it worth it? And I'm asking from both your experiences in moving multiple iOS code bases to Bazel, and also how that compares and contrasts to your experience doing it with Android.
With Apple, you go for, usually people start because the speed, they want to get the caching, they want to get the faster builds. With Apple specifically, you end up getting a lot more than that because, again, you don't have a code-backed build definition language like in Starlark. You have Gradle, what do you call it? Gradle's Kotlin script that powers Gradle. So you get this whole world of more advanced tooling in addition to the actual build speed improvements. So the evaluation is, yeah, my builds are faster, but also I can do a lot more stuff. I can codify my architecture. I can build code gen tools. I can have visibility rules that can prevent developers from depending on the wrong thing. And those things are just foreign as all to Xcode build. On the Android side, you're mostly then going for two things. You're going for that hermetic build, fast build, that is kind of the core Bazel promise. And then depending on what your company values, you might value using one tool for multiple platforms, the polyglot story. The first one is more measurable, whether it's worth it or not, subjective. The second one is purely subjective. Is it a value to have one team doing both build systems, or do you like to kind of have two centers of excellence? Probably a bit more easier to maintain a Gradle build, but you do need that kind of one expert in one system and one or the other. So it's I would recommend Apple for a lot more teams easily, especially if you're a moderately big shop, but way more subjective per team basis for Android.
Yeah, I mean, I think we've covered, some of the costs of kind of doing a migration like this. You're certainly always going to be lagging behind what the Android Gradle plugin is implementing or what Xcode's implementing. So you have to realize that you're signing up for a lot of work as kind of things evolve. But I'd say one hidden kind of benefit of doing a big migration like this is you find the other people in the community who are working on the same problems. And I will say the Bazel iOS community is amazing. There are a bunch of different companies working on the same problems and kind of sharing solutions. And that's just been a really good way to kind of concentrate that knowledge and share it across the industry.
Cool. All right, I want to open this up to audience questions. So I think I'm going to bring down this mic. I'm going to bring this mic down there. I have one ask, which is please get close to the mic. It's very sensitive to distance, and it's very loud with this AC setup over here. So yeah, lean in, talk loud, and yeah, we want your questions.
Hi, Dave Kerber. I work at Chase. I wonder if you can go through and tell your experience about going through and building custom Gradle plugins to go through and help manage large scale projects. So you got 50, 60 different projects, all needing to use similar type of configurations.
I feel like Zach might be the best person to speak to that.
I have no responsibility here. It's all you.
All right, all right. Well, yeah. I mean, at Slack we were building some custom Gradle plugins. I think the kind of model for the best way to ship your own custom Gradle plugin internally has kind of changed over the years within Gradle. I think that's kind of been a sore point. Is occasionally you'll like make a change in your plugin and it will invalidate the entire build and slow everything down. But I think it's a really powerful tool to kind of enforce conventions and kind of create the API that you want developers to have, rather than just Android Gradle plugins API, which has every feature you could want. I think I also, Zach probably knows better than I do, but back when I was doing this frequently, the best workflow was to kind of actually build your plugin as a binary and publish it to some sort of artifact repository and then fetch it, because having it compile as part of the Gradle build was a little complicated and performance sensitive. So.
Build source is the way to sadness. I have a quick follow-up onto this for Inaki. Anything you want to add to that, maybe in the context of declarative Gradle, which is another thing kind of on the horizon?
Sure. So declarative Gradle, if you know, is a purely declarative language for Gradle. So last April, we have a EAP, so the third one. So we are still working on that, or Gradle is still working. And the idea is that it's purely declarative, no loops, no conditions. There is only one way to build the stuff, right? So that's some complaint that people has about declarative Gradle. And the build tool team told me that we are going to have a new EAP at the end of the year. So the idea is that it's going to replace not the KTS, not Groovy, but the idea is that for a feature developer, it doesn't have to be a Gradle expert. Today, if you want to set up a model, you need to know about plugins, about, I don't know, so the tool chains, about the different configurations of the extensions of the Android Gradle plugin. And if I am a feature developer, I just want to work in a composed feature model. I don't need to know anything about the build system. And that's why we believe that declarative Gradle has a lot of promising future, right?
Hey, I was wondering what the panel's opinion was on Gradle maybe being the wrong abstraction for most developers. Maybe in the future, we transition to something like what's there on web development, like YAML-based configurations.
Like declarative Gradle type?
That's good.
Inaki, what are your thoughts on Amper?
Well, I mean, personally, and I mean that I think that always, right? So having Bazel, Amper back is going to be positive for the Android developers, because what we want at the end of the day is the best experience, right? So, and competition, right? It's nice. So, I mean, yep.
Hey guys. So we talked a lot about betweenness centrality and finding bottleneck modules in your build graph. But let's say once you identify a module that becomes a bottleneck, what are some tools or strategies that you have used to decompose that into separate modules, pulling out code that is should fit together?
Yeah, so for me, I forgot the name of the tool, but there's like a visualization tool that kind of shows the graph diagram. But if you, based on your the size of code base, it can be like really hard to follow, or it can be like much simpler. But like for our case, yeah. So as I said, we only have like a 500 modules, and it's pretty much flattened. But there's like a one kind of legacy module it's called common. So you can guess from the name, like everyone just dump everything that's being shared in that module. So you've got like a really like a big bottleneck. And then some of the strategies that we kind of took to kind of like break it out to like a different module is that we first kind of set up like how we are going to. So if it's like if it becomes to like another like shareable modules, then what kind of API we are gonna expose and what kind of architecture that we wanna have. So based on that discussion, like we kind of look into the code and then kind of extract out. We did like a class by class basically. So some of the things that can be extracted out, like we took it out from and then put it in the right layer of the module. Yeah.
Gotcha. Did you use any tools to identify like clusters of code within that single module that like talk to other parts in that module?
Yeah. So I cannot remember the name of the module, the name of the tool, but after this session I'll look up and then I will share it with you. Sorry.
Hi. So my question is, we have all these different tools for Gradle build, and that's great for performance analysis, to enforce conventions, etc. One of the things that we struggle with is the lack of cohesion of engineering culture and beginner experts thinking that this way of modularization is the right way. I'm going to go do it. And when you do that in a monorepo with 1,000 modules, that causes problems. I was wondering if any of you could expound on wins where you've had educational moments with other engineers to essentially tell them, this is how you do Gradle, not the way you've been doing it. Especially engineers coming from FANG organizations, bringing it down to a place where that type of, or that sophisticated engineering doesn't solve the problem here. Yeah, stuff like that.
Would it be safe to summarize that as like, how do you make it approachable to people who are not intimately familiar with Gradle
Yes.
or Bazel?
There's a really good series of blog posts by Tony Robalik at Block. I think stampeding elephants, herding elephants. And I feel like the kind of bottom line of that blog post series is like treat your build system code as like regular code that you do like software engineering on. So it's like, create abstractions, write tests. And I think I think one problem with the configuration model of Gradle is it's so flexible. You can, copy a script from Stack Overflow that like does a network request as part of the build, and cargo cult that around your code base. I think just kind of putting some guardrails on and like being, just sort of a software engineer about it is kind of the best way, so that people have models of like what a module should look like. And they don't have to kind of find their own solutions.
Maybe answering or not directly answering your question, like one of my personal North Stars, and I think any team I've been on has been, from a developer experience perspective, which is oftentimes like your build team's perspective, is that developers should fall backwards into best practices. So you got to assume that you're going to have like your super sophisticated senior developers all the way down to like 19-year-old intern out of their freshman year of college. And you need to design your system around both of those user stories. Or you need to be intentional about that you are not solving one of those. And I think if you start from a North Star like that, your solution or answer to that problem should follow naturally. If you do follow that, this should be an accessible code base, that should, then you debate around your scripts, your plugins, your tools that create your modules or create your builds, and you debate how those work more than directly how should developer A, B, or C not make some complex module design on their own.
Yeah, more on the Android tooling. I would like your thoughts on the monorepo versus the polyrepo and like how you handle this inside the teams and what your choices on that one. What do you think one versus another?
How many mono repos can you have in one mono repo?
Every company except Google has many mono repos. Everything's a mono repo if you just set your bounds right. I think that it really depends on your tools a bit too. Like I know it's Slack. Android is more, I don't want to call it polyrepo, but Android, we have code outside of our main repo that is then built and fed into a Maven repository. And I guess you could kind of call that polyrepo, but really most of Slack is one repo. But to the point is what you're trying to do is you're trying to design a developer workflow. So if you say I want one repo or many repos, you have to think through the developer story. Usually the vote against polyrepos is if you're spending all of your time changing SHAs or versioning every day, that might be a sign that your repo design is not working in your favor. But if you have many customers, many clients, and there are many repos, and that's a feature of your org design, that may be the right answer. I think most teams probably benefit from fewer repositories because it is the version hell is a real drag to anybody that has to deal with it.
Yep. So I'm going to give you an answer from the build perspective, right? So, I mean, when you have like a huge project, you're going to have bad experience in terms of configuration and IDE. So trying to have like a decomposed project with binary instead of sources, right, is going to be beneficial always from the build perspective. So yes, from the Gradle side.
And then I'll just counter that. I'm totally mono repo build, and your tooling should support building those things from source, putting them in a remote cache, and fetching them. So yeah, I just think getting rid of those kind of versioning troubles and having to update things, and some team releases a new version and you don't upgrade, and then you only realize a month later that things are broken. I think mono repos just fix a lot of problems, even though they're hard to manage too.
If your APK has 14 megabytes of custom emojis, put that in another repo.
Hello. Platform teams can be viewed as teams that should empower other teams with tooling. But on the other hand, they might face an ownership problem sometimes when a big or highly central module from a feature team is affecting performance of the tooling, causing CI to be slower than it should. How have you dealt with this issue in the past in your context? And do you have any advice for smaller platform teams that are struggling with this?
Very open-ended, but I kind of want to scratch in this one a bit. Every company is different on who owns or is responsible or is accountable to what slices of your organization. And in your case, you have a platform team, which is kind of, I'm guessing, tooling, builds, overseeing, like developer enabling, but you also have some actual like code that may or be not in the position you want it to be in, and you want to invoke change on that. Is that kind of what you're kind of getting at?
Yes, very big module or highly central causes recompilation of many others.
So at Slack specifically, we have a part of our culture called Health Score. And the nice thing about a thing called Health Score, and I'll give you a bit on what it is if you have a set of values that you agree to as an organization, you kind of convert that to a number or a scoring system. And so what I like about that is if the change you want is we don't want big modules or we don't want slow modules, instead of going to a team and saying you're big and you're slow, you say, you kind of dehumanize it a bit and say just you give some code a score. And a team is then responsible for minimizing or maximizing that score. So in that case, what I'd love to do is say that Depending if the big module problem is that it builds slow, or if it's confusing, or like whatever reason you have for moving it, make that a metric. Say that we don't want any module to take more than 15 seconds to build. We don't want any module to have more than, I don't know, 100 files is too many. And you just say that we will duck the score of this element for practice until our tools say this is no longer a problem. And then you socialize that with leadership. The manager gets to be part of their like direct responsibility, or the VP's like, all right, let's go, let's make the score better. And so then it kind of becomes more of a rallying cry or carrot than what doesn't work for platform teams, which is the stick. Sometimes you got to use a stick, but we try to stay away from it as much as we can.
Thank you.
All right, I think we have time for maybe one more. No, we're done. All right, so thank you all for coming. Thank you to the panel for taking questions. If you have any other questions or you want to talk to them, panelists will be hanging out here onto the side. And someone from the Gradle build tool team is also going to come hang out up here after. Yeah, thank you all for coming.